the new location?
No, that's going to be here. February is the new location.
Oran just told me it's there.
Yeah, but...
Anyway, don't listen to Felix, just listen to me. And so it will be in the invitation anyway. So it's going to be Pascal was sitting right here, was talking about Angular and Angular 2. And then in March we have one scheduled about Go. And with that, I'll hand it over to Christoph. You are to know in the last 9 months. You're going to introduce yourself in detail.
Yeah, sure.
And talk to you later.
Okay.
So, hello everyone. How's everyone feeling today? Everyone feeling great? Okay, because I actually woke up with a sore throat, feeling really bad, and now that I see you, I feel much better. So, so who did anything with Rust so far? Who's interested in Rust? So you can probably help me out when I start talking nonsense here. Okay, anyone else did some system programming stuff, like with C or C++? Okay, great. That's awesome. So you are probably much more advanced than I am. Okay, so yeah, this is about Rust. This is me and with my daughter. And you see, this is before I discovered Rust. So my world kind of was like gray and like I had no beard. And you see, like, all those system programmers, they really need to have a proper beard and all this. So then when I discovered Rust, yeah, then my life totally changed. And there were colors, I had a beard, and so you see, like, it can have a real impact in your life, yeah? Starting with Rust, it's not just another programming language. Okay, let's talk about Rust seriously. So first, an important thing, like, I'm not a Rust expert. It just happens that I wrote some Rust libraries. I wrote a web framework called Nickel that I will talk about later. That's quite popular in the Rust community, and also a library called Clock that you can use to generate change logs. That didn't happen because I'm particularly smart. It just happened because the Rust community is quite small still. So you can make an impact with such projects early on. So yeah, take it with a grain of salt. I'm not really an expert. Yeah, it's just a language that I'm pretty excited about, and I hope I can excite you about it as well. So there are mainly 3 things that I would like to talk about with you. So the first thing is, why Rust at all? I mean, why do we need yet another language? I mean, we have plenty of languages in the languagescape. And I think, like, every time we introduce a new language, it should bring something unique to the table, right? We just don't want to learn yet another syntax. Yeah, that would be just like waste of time. So I want to talk about the motivation behind Rust. I want to talk about Rust features, and this is the part where I really have to cut things out because Rust has lots of awesome features. So the list is quite long. The time is limited. Actually, we have quite a lot of time tonight. So I put some extra things into the slide that I didn't show off before. Yeah, I want to talk about that. And then last but not least, I want to talk about this Nickel framework that I mentioned. That is a web application framework that I wrote, where I actually have like, I'm glad nowadays I have much smarter people working in the team, much smarter than I am, helping me and actually make me learn so many new things about the language every day. Okay, so that's our program for tonight. So why Rust at all? So today we still have like certain fields in programming that still need something like C or C++. So for instance, when you're writing an operating system, you can't really write an operating system in I think like Java or .NET. Or when you're writing a web browser. Like for instance, a web browser has to do like rendering, and this needs to be like really, really fast, yeah? So basically, you can't do that in another language beside like C or C++, so far at least. or like with gaming. It boils down to like all those areas where like the notion of real time is a real thing. Yeah. Like if you think about like writing a garbage collector, for instance, you can't really write a garbage collector in a garbage collected language. Think about that. That would be quite insane, wouldn't it? Like you need to have full control. You can't afford that a garbage collector at some point stops your program, yeah, and does some things. You just can't afford that, yeah. Okay, so those are areas where we still need C and C++ today. And when we look at what does C or C++ actually offer to us, well, first of all, you get like direct memory access, yeah. Like you can really work like direct to the bone, which also makes it quite efficient and fast. You have something we call zero cost abstractions. And what that means is that in programming we always build up on abstractions. Yeah, we use things like hash maps, lists, all those kind of data structures. And the thing is, when you look, for instance, into the implementation of a list in Java, yeah, you have like lots of indirection going on behind the scenes. Yeah. So with zero cost abstractions, what we mean is that you should not pay for the abstractions that you use. So if you're using abstractions in your code, the code should still be as fast as if it was like handcrafted C code or handcrafted assembly, like in the perfect world. That's the ultimate goal. That is what we mean with like zero cost abstractions. You don't pay for the abstractions that you use. No garbage collection. Yeah, this is also what C and C++ offers. And it's a compiled language, obviously. So what's actually wrong with C and C++ then? Yeah, why do we need another language? So the thing is that in C and C++, you get all this nice freedom that you can just access memory and allocate memory and all this kind of stuff. But you have to manually manage the memory. So you have to deallocate it yourself. Yeah. And this is, I know that like folks of you like that are following like C++ might say, hey, that's actually not true for C++, because like in C++ 14, you actually get lots of safety already, like in modern C++. Still, however, you have to play according to some rules. Yeah, you can still write bad C++ today. Yeah. But yeah, situation got much better with C++, so I'm not here to badmouth C++. So yeah, you can get like seg faults, yeah, when you just like, you freed some memory and then you try to access it, then you get a seg fault, yeah? Where you free some memory and you free it again, you get a seg fault, yeah? So those are the things that are quite bad in C++. Also some language flaws, like you're probably aware of this diamond problem, and I'm not going too much into this kind of stuff, but yeah, it's a drone language, yeah, with like putting features on top on itself. So you have like data races where like multiple threads are fighting for something, and then depending on which thread wins, you get a you get into a state that you don't want your program to get in. So yeah, those are the things that are like bad with C and C++. Yeah? And the thing is, like companies like Mozilla, they feel the pain, yeah, of writing C++. They have a large C++ code base, yeah. And when we look like historically, we always had this trade-off, yeah. Like you see here on the left bar, you have control, and having full control always also means like having full performance, yeah, because you can tweak things. So we always had this trade-off. You had language like C or C++ that offer you full control, lots of performance, but are really poor at safety. Yeah, you have to manage all this yourself. And then you have stuff like Haskell, yeah, where you can say, okay, if it compiles, yeah, then it's safe, yeah, it's doing the correct thing, but you don't have the full control, yeah, and then you have stuff like in between, yeah, but it goes like this, yeah, you always have this trade-off. So Rust, if we look at the spoiler from the website, yeah, it says Rust is a systems programming language that runs blazingly fast, prevents almost all crashes, and eliminates data races. So what that means is that in this diagram, in this chart, Rust is actually there. Yeah. So Rust can give you the same performance of C and C++ code, but offering the same safety that like Haskell code. Yeah. If it compiles, you won't ever have a seg fault at runtime. Yeah. So that's the promise of Rust, and this is what makes it exciting. And I hope this gets you excited about the language. So if you're excited about that, then there are more exciting things actually. Like the governance of Rust is really cool. Like it's as I said, it's created by Mozilla. Yeah, they feel the pain of writing lots of C++ for their browser. Yeah. It's an open source, it's really a nice open source poster child. Like if you're a language nerd, yeah, if you like to get into languages, this is like heaven, because like all the decisions they take, they are like transparently made on GitHub. They have a nice RFC process where they discuss things over and over, and really nice to follow the development. Lots of external contributors, yeah, this really nice. So the zen of Rust is really to be like a modern C and C++ replacement, yeah, where you have like memory safety without garbage collection. You don't need a runtime, so like not like in Java where you have like a JVM, or like in .NET where you have this .NET runtime. You have a really rich type system that we will like see in a moment. You have some functional programming influence, actually quite strong functional programming influence. So sometimes people say like Rust really feels like C meets ML or Haskell or something like that. You have a great package manager that is Cargo. That is like if you are like coming from the JavaScript world with NPM and all those kind of tooling, then you should feel quite familiar. It's awesome. The package manager is really nice. Questions at the end of the talk, please.
I just wanted to comment what you said before about the segmentation calls.
Yeah, but maybe we can do that at the end of the talk. Okay, so let's look at some Rust features. Okay, so there's one quite unique feature of Rust that is ownership. And you can't really give a talk about Rust without going into ownership, but I will go briefly into it because I still want to have time to talk about other stuff. But you can't really talk about Rust without talking about ownership, because this is what makes Rust memory safe without the need of a garbage collector. This concept of ownership. So, but before we talk about ownership, let's understand what garbage collection actually means. So here we have some simple JavaScript code. So this is ES6 code. Yeah? It's just a circle that gets a radius and has a method calc area, and then it calculates the area of this circle. Yeah? Okay, so then we have some code, a function that's called calc circles. It gets the number of circles and the radius, and just loops. It loops through the circles, creates a circle for each iteration, calls calc area, and then returns the area to us. Yeah. So, and like in programming language, there are like two main data structures. That is the stack and the heap. So, who's familiar with stack and heap? Okay, awesome. This is quite a good audience. So, let me quickly say, like, the stack is like for each function that runs, yeah, we allocate some memory called a stack frame, yeah, that is memory for that function to run, yeah, and we like when the next function is called, yeah, we just stack those those pieces of memory on each other, yeah, those stack frames. And as soon as the function returns, yeah, we just pop the allocated memory back. Yeah, we just free it again. And this is how the stack works. Yeah, and this works for when your function, when you know the size of your function. Yeah, the amount of memory it takes. Yeah. If the amount of memory needs to be growable, then you need to put it on the heap. Yeah, because then you can ask the operation system, hey, please give me some more memory. Yeah, I need more memory. You can just ask this from the operating system. So when we look at this code, yeah, where we create new circles, like in a perfect world, yeah, we could just say like, okay, those new circles that we create, they can just live on this stack, yeah, because it's not escaping, it's not growing, yeah. We could just put it on a stack, and then the function returns, it goes off the stack, and yeah, would be the most efficient. In a language like JavaScript, like most things actually go on the heap because it's getting quite tricky. Like if you take things like closures in account, the VM can't really know if this is safe to allocate on the stack. So most things in JavaScript actually go on the heap. So when we go through this and we create a new circle, then a circle object is stored on the heap. Yeah. Actually for each iteration. And at some point, not when the function returns, yeah, but sometime later, yeah, a garbage collector kicks in. And basically when I say it kicks in, it means like it has some freeze the world mechanism. It basically freezes your program, and then it looks for allocated memory that is not referenced anymore. Yeah? And it will notice, okay, those three circles, they are not needed anymore, so I can free them up, yeah? Because nothing is pointing to it anymore. Okay, so this is how a garbage collector works. So, with that in mind, let's look at some really simple JavaScript code. So here we say we have a function getVehicle, it gets us a vehicle object, and we have a booking service and a repair service, and we pass the vehicle to those services. Yeah? And so this means like both booking service and repair service now hold a reference to vehicle, right? If we look at the same code in Rust, this actually doesn't compile. So you see the syntax is a little bit different, yeah. So, but it's basically doing the same. Yeah, we get a vehicle. We call new, which is like, it's just a function called new, but you can consider it as a constructor, if you will. So, and this tells us, hey, we can't actually, I have this nice pointer that I can use. Use of moved value and vehicle, yeah. It's telling me I can't do this here, yeah, because vehicle already moved when I call booking service new vehicle, which is, yeah, kind of weird if you see it for the very first time. So you may be wondering, okay, what's going on there? So there is this ownership system in Rust, and basically Rust moves ownership by default. If you pass an argument to a function, it moves ownership by default. And the owner has the right to destroy the thing it owns, yeah, to free the memory. So the memory is freed as soon as the thing that is owned goes out of scope. So in our example here, yeah, when we pass, go back, when we pass vehicle to this function here, yeah, we must assume that vehicle is actually the memory is actually freed, yeah, because we moved ownership to this function, yeah, and the owner has the right to destroy it, and as soon as it goes out of scope, it will be destroyed. So this code, it's not legal for us to use vehicle then in the next line here, because we need to consider it freed. Yeah. Okay, so you're probably wondering then, okay, then how am I supposed to write any code actually if like those simple things are not working, yeah? So the answer is you don't. No. So you can learn things out. So there is this concept of borrowing, and you may notice that there is this little ampersand here, and this says, okay, I'm not transferring ownership. I'm just borrowing. I'm lending the thing out, the vehicle in this example. I'm lending it out, but I'm not transferring ownership. So ownership stays where it is. Oh, the variable vehicle is still owned by the containing scope here. So this means I can pass it to another service just fine. Yeah. Okay. So there are some borrowing rules. References are passed without transferring ownership, and basically we are just transferring a memory location. Yeah, just a memory address. Yeah, and that can be looked up then. Yeah, you can borrow like immutably with this ampersand, or mutably with this ampersand and mute, the mute keyword. But you can't do both at the same time. Yeah. You can't say I'm borrowing this mutably to somewhere else, yeah, and then to immutably to some other function, yeah. That you can't do that. So when you're like designing libraries or generally writing code, it's more polite to design your APIs to not take ownership, but to take to borrow things instead. Sometimes you need stuff like shared ownership, where you really need like multiple things be the owner of something, and this is done through special pointer types. Like there's stuff like RC or arc, mutex, which are like special pointers that enforce the same rules of ownership at runtime. Yeah. But I'm not going too much into that actually. So, and with those rules, Rust achieves safe memory management without garbage collection. Yeah, and this is actually like the most unique feature of Rust, yeah, because no other language does memory management that way. Yeah. Okay, so let's talk about let's look at some more Rust code and talk about its features. So in Rust we don't have classes, but we have something called structs instead. And a struct is basically a structure. You can tell it like lightweight classes, if you will. You can define a structure like this without any fields. Yeah, this is just a struct without any fields. You can have fields, like here we have our dog struct. It has a name field that is a string. There's an H field that is an integer, and you can instantiate them. Yeah, we just do it like that. So some braces and pass the name and the age. Yeah. If you try to initiate to create an instance without passing all the fields that you need, you will get a compile error. Missing field H. If you want to express that something can be omitted, yeah, we have an option type for that. That is an enum. I will go into enums later. Yeah, this is a special type that can carry a value, or it can carry a non-value. Yeah. So if we have this, we can say, okay, create this dog without the H, but we make it explicit, yeah. And when we work with our instance, yeah, we explicitly have to check if it carries a value or if it doesn't carry a value. So we don't have null pointer exceptions in Rust. And this is something like the C++ inventor said. It's like the $1 million or the $1 billion mistake, having those null null pointer exceptions. Yeah. So this frees you from like whole kind of area of bugs actually. That's really cool. Okay, so you can implement methods for structs, yeah, just like you could for classes. But the syntax is a little bit different. So you don't write the method directly in your class as like if you know it from like C# or Java or other more traditional languages. What you do is that you write a separate impl block. So here we see a separate impl block, yeah, and we see we impl doc. So this matches the name of the struct, and then we create a function here, yeah, and this function will actually be callable of the instance of my my doc struct, yeah. And this is actually quite cool that we write it separately. We will see in a moment why that is. So there is a Rust feature called traits. And traits are a little bit like interfaces in other languages, but like more powerful. So the first purpose they have is like they are like interfaces. They define a contract. Yeah, you can say, okay, I have a talk trait here. If you want to make your object talkable, you gotta implement a talk method. Yeah. So I can say I have my three structs here: human, dog, and tree, and I impl talk for human. I impl talk for dog. Yeah, and then I just print out some stuff. Yeah. And then we have a function here that accepts a trait object. So we call that a trait object, like this here. It accepts a trait object of talk. Yeah? And I can make instances here of person, dog, tree, and pass a reference to a person, a reference to a dog, yeah, and this will work just fine. I can't pass a reference to a tree. This will be a compile error because it doesn't implement the talk trait, right? Okay. So traits can also have default implementations. So for instance, here I define the talk trait with so not only with the signature of talk, but also with an implementation. And then I can write talk for cat and leave out the implementation, and it will just fall back to the default implementation. Yeah? I could, however, override it here, yeah? But I don't have to. It will just default. It will just pick the default implementation of the trait. So what's really cool is that you can actually write your traits for foreign types, and this is where I come back to the point that it's quite nice that we write it separately, those impl blocks. Yeah? Because for instance, I can write an impl for an integer type. Yeah? That is certainly a type that's not from me. That's from the Rust standard library. Yeah? But I can implement talk for an integer. And then I can just pass a reference to 3 and call talk on that, and this will work just fine. It doesn't make sense, yeah, but it works just fine. And this is quite nice, and it kind of is a bit like type classes in I think in Haskell, but I'm not sure about that. Okay, so this is really quite cool. So you may be wondering when you see this, like, okay, isn't this like Wild West crazy? Like if we can implement traits for like foreign types, so multiple people write traits with conflicting things for a type and stuff like this. So turns out there are some trait limitations that tame the Wild West stuff. Yeah. So the first limitation is that either the trait or the type that you are implementing the trait for must be inside your crate, inside your own code, if you will. Like a crate is like the compiled unit of Rust. Like you have like a DLL in C# or I don't know what it is in Java. It's the compiled unit, yeah, of your code. And either the trait or the type that you implemented the trait for, one at least, yeah, must be in your control, if you will. Yeah? And the second rule is that you must bring the trait into scope to actually use it. So this makes totally sense. So like if you have like a type and there are like two traits implementing a foo method for this type, yeah, then you need to tell explicitly which trait you actually want to use, yeah. So you have to bring the trait in scope, and there's a use keyword for that. We will see later code that actually makes use of that. So the next real cool feature is generics. I guess many people of you will know generics from other languages. So let's assume we have two different types, person and car, and we have some sort of storage, and we call this smart person storage. We don't know exactly what it does. We can add a person, and we can get it from the storage, and somehow it stores them in a smart, efficient way. We don't know what is so smart about it, but it's somehow smart. So the question is, what if we need the same kind of smart storage for cars as well? Yeah? Because now we have this only fixed for persons here. Yeah? So basically, in a language that doesn't have generics, we can give up dry. So we can give up don't repeat yourself. So we would write a smart person storage and a smart car storage and just duplicate some code. Yeah? And then we have like full type safety. You see we have like the car type here in the signature, the car type here, the person type here in the signature. So full type safety, but we duplicate code, right? Or the other option would be to give up type safety. So like in most languages you have like some kind of type that every type matches, like object in Java, for instance. And you could say, okay, we give up type safety here, yeah. So you can put anything inside, you don't duplicate the code, yeah, but you give up type safety, yeah. No one will actually notice when you use your smart storage at runtime and you put a person inside and you put a car inside, yeah, this will totally work without a compile time error. But we want to get a compile time error for that because it's obviously a programming mistake, right? So this gives us a set phase also. So in a language that does generics, what you can do is you add a type parameter, and there's this special syntax with this angled brackets. And you can then say, okay, you make an instance of, I don't know if I have actually, no. You can make an instance of a smart storage for car, and you will get signatures that accept only cars, yeah. And you can make an instance of smart storage for persons. And then the signature will only accept persons, yeah. So you get a compile time error if you are trying to misuse it, yeah. And this is exactly what we want. Yeah? We don't give up dry, we don't give up type safety. It's exactly what we want. And in Rust, you can use trait bounds here. So what that means is that you can say, okay, you can instantiate a smart storage for anything that implements the hasID trait. Yeah. So you can reduce the kind of types that you can use with your generic code. Yeah. And this traits and generics play very well together in Rust. So let's refactor some code that we saw earlier. So, for instance, here, we had this method talk that accepts a trait object of type talk, yeah? And notice that we actually pass references to the types. Because the thing is that this method here, it doesn't know at runtime the size of the object it gets passed. Yeah? Because this could be a human that has like 20 fields, yeah? Or it could be a dog that has like 3 fields. So we don't know the size of the object that gets passed into that. Yeah? And this is why we actually call it with this ampersand, with this reference, because then we are just passing a pointer to the thing in memory. Yeah? So you have this indirection going on, because the pointer always has a fixed size. Yeah? And so you see, yeah, obviously, like each trait has its own talk implementation. Yeah. And yeah, when we call this, the question is like, which implementation of talk should actually be called here? Because at compile time, we don't know which object is actually passed here. We may not know. Yeah? So the thing is that it has to be looked up in what we call a virtual dispatch table, a V table, yeah, at runtime. Yeah? So it has to look up the method that is actually dispatched. And yeah, this is what we call dynamic dispatch in programming language theory. But we can do that differently in Rust. We can refactor that with generic code. So this is the code that we just wrote. And we can also say, okay, we make talk generic. Yeah, it gets the type parameter here. And we use a trait bound, so we say only accept things that implement the talk trait. Yeah? And now you notice that we don't have to use the reference anymore. We can pass the object directly. The reason for that is, I will show you in a second. The reason for that is that the compiler can generate specialized code. So behind the scenes, so this is code that is from behind the scenes what the compiler generates for you. Behind the scenes there will be a talk person method that only accepts persons, and a talk dog method that only accepts dogs. Yeah? And so the size of the thing is already known at compile time. Yeah? So you actually don't have to pass things behind a reference anymore. Yeah? You still can, but yeah, because the size is known at compile time, you don't have to. So, and this is in what we call in language programming theory static dispatch. So it's statically known at compile time which method to invoke. And static dispatch is always faster than dynamic dispatch, where you have to look up the method in a V table. Yeah. So yeah. And this is also what we mean a little with zero cost abstractions. Yeah, that you can write code in a way that is abstracted, that where you don't pay for at runtime. Okay. So, last Rust feature that I want to talk about is enums. And enums are called like the sum type from like algebraic data types. So in programming language theory, you call it sum type. And you may know enums from language like C# or Java, but like the Rust one is like more advanced. So, an enum is like a type that can have like certain states, but it can be in one of those states one at a time. Yeah? So this error enum is either in a critical state or in a non-critical state. Not both at the same time. And then you can, for instance, you have a method here that accepts something of this error enum, yeah? And you pass an enum here, either in critical state or non-critical, and then you can use pattern matching to actually look into the enum, like in which state is the enum. Yeah? carries both, yeah, an integer and a string. And then again, you can use pattern matching to actually get to the underlying data that the enum carries, yeah? Which is quite cool. And the best thing is that enums can be generic, of course, as well. Yeah, so you can have your result enum, which is actually a real enum from the Rust library that has that is generic over T and E. Yeah, so this is a enum that is used across many APIs in Rust. The purpose of this enum is to have a result structure that either carries a value from an operation that went out okay, or it carries some kind of error, yeah? Which can be like a passing error, an IO error, whatever, yeah? Because it's generic. Yeah? So here we see, for instance, file open. This returns us a result, and we can pattern match against OK with a file. We can pattern match against error with error, and you see that this is actually carrying different types. Yeah, it's carrying an IO error, it's carrying a decoder error, but because it's generic, yeah, you can just Oh, my mic went dead. Okay. Good, we have multiple. Okay, so thank you. Okay. Yeah, because it's generic, we can just use it with lots of arbitrary types. So that's cool. And enums can also, you can implement methods for enums. So you can totally write an impl block for an enum. Yeah? Which is really cool. And you can go even as far and implement traits for enum. So here we are implementing the clone trait for the result enum. Actually, this is code from the standard library. Yeah? This is like real Rust code from the standard library. Okay, so I think this is quite cool. I hope you too. So this is it for the Rust features. Yeah? So actually, like there are like lots of Rust features. I wish I could talk about all of them, but I don't know all of them either. Like really grok them. So the last section of my talk, I want to talk about Nickel. And Nickel is this web application framework that I started. So I'm not claiming I wrote all the code. So I want to tell you how this all started. So I think this was some back in, what's this actually? I think this is 2000. Must actually be 2014. Ah, yeah, there it is. Yeah, I was confused by this 15 here. Yeah. Okay. So I was playing with Go at that time, and which is quite cool. And I know like a lot of you are using it, and it was quite simple. Yeah, and I like you use, like if you use Go for a couple of days, you actually like see all the features. So then I wanted to see like if I can do the same in Rust. And at that time, unfortunately, there was just no web stack for Rust. There was no web application framework for Rust. There was a really rusty HTTP library. So it was really not that easy. And I was like, oh, I hope someone starts a web application framework. And like Steve Klapnik, which is working for Mozilla, and he's doing all the documentation for Rust. He was like, okay, maybe that person can be you. And I was like, okay, I just did the hello world. And yeah, then like, I don't know, a couple of days later, I actually started it. And yeah, this became quite a nice web application framework. So in a nutshell, Nickel is a thin layer on top of HTTP, or on top of raw HTTP, yeah? It's pretty much inspired by Express.js. So who did ever use Express.js before? Okay, some people at least. So you probably know it's like super simple to write your a basic web application server with Express. And I wanted something that feels that simple, yeah, in a language that for me at that time looked quite complicated. And yeah, it should be like extensible with a custom middleware, like you know from Express. And oops, okay, that's it. So this is like the basic hello world example of a Nickel application. And I think this actually, like for a system programming language, yeah, this doesn't look too scary, I think. Or does it look scary? Like if you ever seen like Express code before? Not too scary, yeah? Okay, that's cool. So we will go through this like line by line. So the first thing here is that we have to, so Rust has macros. I didn't talk about that, but it has macros, which are quite cool. Like a macro is like some kind of mechanism where you can abstract on a syntax on a syntax level, because a macro expands into other Rust code in the compile phase. Yeah, yeah, we have this in Rust. And if I want to use macros, and I have like a crate, Nickel has macros, yeah, I have to tell the compiler explicitly with this attribute, yet another feature of Rust, that we want to use macros. Then I have to tell the compiler that I'm actually using the Nickel crate, yeah. So the compiled, the binary of Nickel, the library, and then we have to tell explicitly the things that we want to use from the Nickel library. Yeah, so we have to bring this in scope. So first we import the Nickel facade, which is just the facade to interact with the Nickel server, and then we bring the HTTP router trait into scope. And this is what I said before. Like when you are using traits, yeah, you have to explicitly bring the trait in scope to use it. Yeah? So next thing, pretty simple. It's just the entry function of a Rust executable. And here we are creating the server, the Nickel server. And you see this little keyword mute here, which is you have to explicitly mark things as mutable in Rust. If you don't do that, then it's immutable by default. So Rust favors immutability by default. And then you can attach handlers. Like here we are attaching a get handler, yeah, that will respond with hello world, yeah, if we hit /hello, yeah. And yeah, we basically get this thing started by calling listen and giving it like the local host and a port number, and then it starts listening. So we saw this middleware macro here, and this is actually quite cool because, for instance, you can use this with a simple string, yeah, like this. But you can also like give it a block. So here you can set up bindings and stuff like this. So do some code before you actually return something. You also see that there's an implicit return going on because we are not doing a semicolon here, yeah. So it's implicitly returning. You can use the middleware, and this is all the middleware macro, yeah. You can use the middleware macro with getting access to the request object, yeah, and like look into the parameters or stuff like this. Or getting access to the response object, yeah, and like set the content type of the response, for instance. Yeah? So the middleware macro basically allows us to improve ergonomics of the Nickel framework, where the language is still lacking. Yeah? Because the macro is expanding at compile time into other Rust code, yeah, we can do like a little bit like bypass things, make things more ergonomic. It improves like stability on a syntactic level because we can change the implementation that is behind the macro, yeah, and still keep the macro the way it is from the user point of view. Yeah. So we implement like all this HTTP verbs like get, post, put, delete, option, all this stuff. Have some like flexible routing, like this matches like /bar. You can use this asterisk to match like A, B, D, but you would not match A, B, C, D because you have like multiple segments here. However, you can use like this double star, and then this would also match this this route with multiple segments. And yeah, you can have like a middleware. There is middleware that already comes with the Nickel framework, like a static file handler. You just pass it a directory, and then it serves files from that directory statically. But yeah, you can write your own custom middleware if you want. With like JSON support, mounting, so that you can say, okay, I want to mount like all those assets. Images, JavaScript, whatever, to a certain path. We have like error handling that is pretty much inspired by Express, but in a more rusty way. We have encrypted cookie support, session support, and yeah, actually like lots of other stuff. And yeah, that's basically it. I hope I got you excited about Rust. Again, this is me. This is my Twitter handle. I'm C. Burgdorf on Twitter. I work for my own company, ThoughtRamp, together with Pascal. He's sitting here and giving the next NewStore TechTalk. We do workshops about Angular and Git, like all across the world. And yeah, thank you very much. So I think we have time for questions. Yeah.
Nice talk. How easy is it to connect from Rust to Postgres databases, for example?
Actually, there is already a library for that.
Yeah.
And there's even a connector for Nickel. So if you want to use this for like a web project,
Yeah.
then Nickel Postgres, there should be something like this. This even has some examples.
Can you zoom in?
Yeah. So yeah, I haven't used this myself, but you can get your like this. Yeah, you can get a Postgres middleware. Yeah, I don't know, like, okay, there's SSL mode, whatever, I haven't used it. But yeah, there is support to use this, yeah.
Do you know if that's native Rust or if it's just a wrapper around some C or C++?
That's a good question, actually. I don't know, but I think we can probably look that up.
Okay, I suppose, yeah, sorry.
Wait. So let's see. So this is the cargo toml file. So if you ever used like npm, you have a package JSON, yeah, where you define like all your dependencies. This is your package JSON in Rust. It's called cargo toml because it uses toml, which is inspired by YAML, I think, but like a little bit better actually. And here we see the dependencies. Okay, this is a dependency against Postgres. So now we could look on crates.io, which is the website of the package manager, and look for Postgres. So here we have it. And then we look at the Postgres repository. And there we could go deep into that and look how it's done, but yeah, maybe have a short look at their dependencies. So I'm assuming this is going natively against the Postgres database. Certainly don't know from the quick look, but I would assume it does.
Looks a bit.
Sorry?
Looks a bit like it.
Yeah. Any other questions? Yeah.
In your first Nickel RS example, you had this to mutable. Why did it have to be mutable there? Because it didn't really change anything. They just called a few functions.
That's a good question. So, like this. So here, the question is, why does this have to be mutable here? Yeah. So the point is that we are registering, like here with this function get. Yeah. We are registering a handler. Yeah. Inside of this server. Yeah. So this is actually mutating the server, yeah, because we are storing a handler here on the server.
Okay, so I actually have to know what the get method does in order to know whether it has to be mutable or not.
It will if you forget the mutable keyword here, Rust will give you like a very detailed, nice compiler error telling you that you need to make server mutable in order to call a get here.
So that's kind of the workflow.
Yeah, you
do it without mutable first and then compare to that absolute.
Well, basically, like if you are like working with the nickel library for the very first time, you would probably maybe run into that because you would first try without the mut, maybe, but then you will get a really nice error message telling you that you need to make it mutable. Yeah.
You can see it
if you work on this kind of stuff, so if I see this, for example, I know it calls get on server. So if you implement functions on an object or struct that server, then you have three options of calling it. With self, you're just giving ownership, like a borrow with a little ampersand behind, which says that you can't change it, or the mutable borrow. And in this case, I would expect it's just mutable borrow, so that's why you have to make it mutable in order to be able to change it.
Exactly. There was another.
If you note, there are three options, and that's
There was another comment. You can just look at the type signature, which is definitely true. The IDE support is like there is there's a project called Racer that gives you a low-level abstraction where IDEs can build up on. And for instance, I'm using Atom with Racer integration, so I can actually get like a signature. I can see the signature of functions, and then I would see like, okay, this takes it mutably. So yeah, I will get a hint about that. Any other? Yeah.
I have two questions.
yeah.
Actually, I think you also had a question, yeah?
Yeah, well, actually, it's a very new question because this is the first time I'm working Rust. I was wondering, how do you run this?
Just invoking the binary. So this produces binary code for a specific platform, yeah, Linux, Mac, whatever, and it produces a binary file that you just invoke.
Yeah.
And then it runs. So there's no runtime. Yeah.
My experience, there usually you use a macro because the language lacks. So my question is, why did Rust introduce macros, and why is this not perceived as a bad thing by the Rust designers or by the Rust community?
I think it just lets you, well, like it lets you do things that are, like for instance, a macro can generate code for you. Like if you want to, you have a trait, yeah, and this trait you need to implement for different structs, yeah, and you can either say, okay, I write the implementation for this trait for each struct, but maybe the implementation for each struct would look like quite similar. Like for instance, there is a clone trait, or there's a debug trait that makes objects printable, yeah. And you can have a macro that does that work for you. So you can just put this macro on your struct and say, hey, implement this this debug trait for me, and it will generate the code for you, the impl block and stuff like this. Yeah. So you can abstract on a more complex syntactic level. So I think
it's a great example.
Mhm.
So I had to earlier on also in C and C++, and now in C++ I would write a generic function. So that's what I mean. There is a you define that some language feature. You replace it with a missing language feature.
okay, you want to?
Yeah, I would like
Smart.
to. I mean, I'm not very deep into C or C or C++. But if I recall correctly, then macros are mainly used by the preprocessor to dump stuff in there. Macros and Rust are a bit different. Like the idea why you use them is not because the language is lacking, but to reduce boilerplate. So it comes from the idea of don't repeat yourself. So for example, if you have the print line macro, it's actually a couple of functions behind it. And instead of writing them out explicitly, you just use this.
Okay, but there you could say, okay, why are a couple of instructions? Because in other languages you just have like a simple print function.
Because it's unsafe in this case. Like printing using IOs is just like unsafe.
I think it's mostly because it doesn't have very any functions.
But the thing is where I meant like we use this sometimes like where the language is lacking. Like for instance, you have this type inference and lifetime elision, and there are some corner cases in Rust today, for instance, where the type inference isn't strong enough. So you would have to write actually types explicitly, yeah, and you can actually hide this behind a macro, for instance. Yeah, so there are some kind of tricks that we use in Nickel to improve ergonomics there where the language is lacking. Yeah. But for instance, you can like generate like a whole. For instance, what I recently did is. I wanted to generate like a couple of functions on a struct that all follow a pattern, like do foo, do bar, do x, do z. Yeah, where all those foo, bar, x, z are corresponding to names of some of something that I load from a TOML file, for instance, or from some file. And I want to generate those methods on the struct, yeah? And you can totally do this with a macro. Any other questions?
I have a question. How the package manager is working? It downloads the source code and compiles it on the first time.
Basically, yeah.
Okay.
And it's caching them to not compile them again if it doesn't have to.
So it doesn't download compiled version.
I think like if something has like a binary because things can have like binary dependencies statically
Because
linked.
then you will have the questions when like using many platforms or it's.
So basically it's loading the source code and and generating then the platform specific binary for each platform. I think like the cross compile feature still can be improved. I'm not quite sure about the state today. Like at least a couple of months ago it was like that you would have to compile on the architecture that you aim to produce the binaries for. So you would have to compile on Windows to produce Windows binaries, compile on Linux to produce Linux binaries and like that. And I'm not sure what's the state of cross-compiling, where you can just say, okay, please spit out binaries for Mac, Linux, Windows. Mm-hmm. I know that there's being worked on, but I'm not sure if this is finished yet.
Mm-hmm.
Yeah.
So I have two questions.
Okay.
One was related to this macros. So it seems like, based on what you described, it's more of a syntactic abstraction.
Mm-hmm.
And in some languages, they allow you to write DSLs into introduce new operators, new kind of syntactic
Mhm.
forms, they're more succinct. Is it something that Rust also allows with this macros, or is it just for code generation?
Yes, to some extent. To some extent, yeah. You can introduce some new symbols, but this has limitations. I'm not too deep into macros, but I know it's possible to some extent, yeah.
And the second question was, so system programming, based on experience with this web framework, was there any element of system programming that Rust supported that made you feel different when implementing a web framework in Rust compared to if you do it in JavaScript or something else? So, like the concurrency model it has, or what about it? What about system programming that it offers made your experience different with Rust?
So that's a good question. Like I think people argue that for web stuff, Rust might not be like the perfect candidate because like web is like often like the stringly typed. Yeah, you return, you're dealing with strings quite a lot. This is like perfect for a language that is more dynamic. We will see like what the future brings. For me, actually, like working with Nickel feels quite nice actually at this point. You certainly get benefits for performance, yeah, because it is like it produces very fast, efficient code. Yeah, so there is a harder learning curve involved. Yeah, so it definitely is a little harder to use than like Express.js. Like even if it gets close to it. Yeah. Okay. Yeah.
So at the very beginning, when you explained deborrowing, you said like if you just pass a reference to functions, the problem is solved. One word that if you pass a reference to a variable, that this is behind the scenes looks like a reference count to it. Because when does it know when the variable can be freed then? Because still the references in the functions can be used throughout, I don't know, concurrently, right? Is it like a reference count if I pass a reference?
No, this is not reference counted. The thing is that the ownership isn't transferred to that other method. So it will just like as soon as it returns the function, the ownership gets back to your to the scope to the outer scope where you call the function from.
What is it? So there were like, if I remember the code, there was the variable and there were two function calls and then the method ended. If those two functions are asynchronous, the outer method finishes first and
Rust will tell you if you like try to do things that are like not legal, yeah. Like when you say like asynchronous, like with the thread, and you want to share this data, yeah. Then Rust will tell you, okay, you can't do it that way, and then you need like special pointer types, like this arc type or mutex or RC, yeah, that enforce those ownership rules at compile time. Yeah, but this will be you will hit a compile error if you try to do such things, and then you have to use those special pointer types. Okay.
My question is that you started with the application thread unit Rust, like a system programming and all this stuff, and now you do a web server where you usually can scale by just adding more workers.
Mm-hmm.
So you don't need here this kind of speed because you can just add more servers or more workers or more trees, whatever, and it will scale quite good. So do you see the real business application of your web server?
It's a good question. Like you have to take into account that for now this is just running each handler on a new thread. Yeah. So like if you compare this to how, for instance, Node.js works, yeah, you have this event loop and then you have like async IO, yeah, And this is not how this works right now. Yeah. The cool thing is that in Rust, like many features that are like language features in lots of languages, in Rust are actually like library features. Like for instance, I said those pointers, yeah, arc, rc, mutex. Those are not special syntax in the language. Yeah, those are like library objects. Yeah, and the same goes for this abstracting over like should we use like async IO or like span new threads. Yeah, so there is a library called metal IO, or in short Myo, that does exactly the same way Node.js does it, with an event loop and async IO. And I think like for like the last couple of months they were actually working on the Windows support. So it didn't work on Windows yet. And I think they just finished the Windows support, and I think that the plan is, I actually have to discuss this more with my team colleagues, but I think the plan is that we want to migrate Nickel over to use Metal IO behind the scenes to get async IO as well. Yeah? Because for like scaling a large application, async IO is actually good for this web server stuff where you have like lots of invocations handler. Yeah.
Well, the question is quite interesting. Why wouldn't you just run this on, what was that, Express?
Yeah, the question actually was that not actually the server is not good enough. The server can be good, but really you don't need to write the code in Rust. The code, for example, you make a code on the web server and it does some stuff like queries to the database or whatever. And actually, usually the real server code is not the bottleneck. The bottleneck is the database or like some kind of calculations that you don't do in the server. So actually, the language, for example, you can do it in Ruby. It will be nice, and the language is not the bottleneck. I agree that the Ruby will be much slower than the Rust, but this is not the bottleneck because the bottlenecks are different stuff. So actually, there is no real reason to write the web code in Rust.
Well, depends. Like I mean, yeah, safety guarantees, and also you get like a much lower memory footprint, which certainly has an impact. Like if you are running like a large data farm, for instance, yeah, then the memory footprint is actually like you pay for it. I mean, this is why companies like Facebook invest into languages like D. Yeah, where they can really optimize like memory footprint of things, yeah, because it's actually costing them money. So
there's also a completely different application. Every smart thing now has a web server built in, like your light bulbs have web server
True.
built in. And then if you get into these systems with very limited resources, it might make sense.
True, yeah.
Sorry. In terms of productivity, just you program in JavaScript, for example, before. Could you say something about that? Like, were you significantly slower using Rust, or was it surprisingly fast, considering that you are...
You mean my development speed?
Yes. I mean, once you got started and once you actually knew the language, then, like, naturally, but...
Well, like, if you have to take into account, like, those days where you are just not making any progress because you have to go to Stack Overflow to write a question because you don't get the most simplest things actually, then probably the development speed was a little slower in the beginning. Now, I mean, we are actually using this for multiple projects right now. We have a project for ThoughtRam that we call Classroom, where we use as a platform to serve our learning material to attendees of our workshops. And we are running this on a Rust application on Heroku. It works quite well, and for me it's nowadays quite easy to write new features in Rust for that, because I have my certain amount of Rust knowledge that is quite enough to make real applications. So now I'm actually like at the same speed probably, if I'm not like, maybe, I don't know, like if I'm doing a completely new feature where I have to talk to a database, for instance, I might hit new complicated stuff, I don't know. But for now, I'm actually feeling like I'm quite quite okay in development time. Mm-hmm.
Do you think the syntax of the language is stabilized now and is not going to change anymore, or what do you think about?
The syntax is stabilized, so the Rust is at 1.5 right now. And they take Samba quite seriously. However, what they do allow is like breaking changes to fix soundness bugs. So if there is like a soundness bug in the language, they fix this, but they don't change the syntax of the language or change stable APIs. However, there are like still stuff that is marked as unstable, but you can't use this with a stable compiler. Then you would you have to opt in to use unstable features, yeah, and those are still changing, yeah. Okay, yeah. There's one more question. Last question, I think.
One more question. How big is the Rust community?
Oh, this is a good one. This is a good one because I think like the Rust language, for instance, Rustlang on GitHub. I'm pretty sure the Rust language is like the language with the most stars, for instance, more stars like Go or other languages on GitHub. It has a very active Reddit community. Very active on Stack Overflow as well. The community is really charming. Like I've never, and this is really true, I've never met a community that is so friendly. Like I'm the guy who asks like all the stupid questions. If you go on Stack Overflow, you will find a lot of stupid questions from me. And like you always get like really nice answers where you're like, oh my god, I owe you so many beer actually. So the community is quite solid already. There are many people moving over from like JavaScript community, like the package manager Cargo is written by Ycats. What's his real name? Do you know? Sorry? Yehuda Katz, yeah, which you may know from the JavaScript community or the Ruby community. Mozilla actually asked them with their company Tilde to write the package manager Cargo because they did that before for Ruby. So yeah, lots of like prominent faces. Yeah. Okay, I think this is it. Thank you.
So, thank you, Christoph. It was a great talk.
Thank you.
Yeah, it was nice having you here. So, I just want to confirm the next talk is going to be definitely this venue. It's a talk on Angular. It's here, so it's going to be definitely here. So, hopefully, yes.
So he was right, actually.
He was right, yes. Good intuition. So, see you again. Yeah, end of January, you can register on meetup.com as meetup.com website as usually. So yeah, have a great evening. There's some pizza leftovers. So feel free to get a slice and bring them home. And there's some beer left. So yeah. Thank you. And if you don't mind, I would like just to make one picture.
Selfie.